Today's job is going to be fixing this Garmin SatNav. It has been an absolutely amazing SatNav until very recently when it decided that it didn't want to charge anymore. I tested it with a USB port checker, and what it does is it draws, I don't know, a couple of milliamps for a few seconds and then decides that it's not going to do that anymore. And what I think's happened is that the battery's gone a little bit too discharged for the battery protection circuit to recognise. So today it's going to be dismantle, remove the battery and try and force charge it with a DC power supply. Wish me luck. I have here, it's in pieces at the moment, as you can see. But what we're going to do is we're going to try and burn the house down, because I strongly suspect that this is the battery that has failed, and I think it's gone a little bit under its recharge voltage. So what I'm going to do is I'm going to stick it onto this bench power supply and feed 750 milliamps into it, and hopefully I won't set the little girl's table on fire. I did initially predetermine that the battery charging voltage, or its peak charging voltage, was 4.2 volts, where its nominal is 3.7, but if I test it on a voltmeter it's coming in at 3.2 volts, which suggests to me that either the pack is dead, which probably is, or it's just gone under its charge voltage a little bit, and which is why the device itself won't recharge it. So we're going to go ahead and try 750 milliamps, which is half of the pack's total capacity in milliamp hours, which is 1500 for this pack. And we're going to go ahead and see if I can't get it to recharge with a constant current source of 750 milliamps, and that will cut out to a constant voltage source. I'm hoping after about 100 minutes, because that's what the data sheet for the battery says that it should get to. So around about 100 minutes it should reach its peak voltage of 4.2 and switch onto a constant voltage source, where the amps will then drop down to, I don't know, I'm probably going to stop it around that point actually and test it and see what the pack voltage comes out at, and see if it can retain its charge for a couple of hours, and we'll see where we go from there. But for now I'm going to turn it on. And it has gone to a constant current source, which is what I wanted it to do, and it's around 750 milliamps and 3.6 volts. So it looks like, to me, that it is actually charging. In my rush to remove everything from the camera, I actually broke the little plug that was supposed to go back in here. But you know, c'est la vie, these things happen. What I'm going to do is I'm going to put a little blob of solder on each one and exercise all of my solder skills, which are few and far between. But we shall endeavour. A bit of flux. And now to tin battery terminals. Being very careful not to burn the table. That would end very badly for me. After completing the smallest solder joints in the world to connect the battery to the negative, the little balanced chargey lead and the positive, I'm now going to give it a little go, turn it on, see if it boots up. I've just pressed the power button and it is actually booting up, which is actually coming as a bit of a massive surprise, to be honest. When it brightens, that normally means that the OS is loading. It should be complemented by some corporate information, which it is. Remarkable. And here's the usual warning. The colour looks a little bit off, if I'm honest. And yeah. So I'm going to go ahead and desolder the soldered connections that I beautifully made. Very hard there was two. Two off. And the third one. And I'm going to try and put it back into a different SatNav. Here we have the new old SatNav and the battery. But because it's Garmin, everything is ever so slightly different. Well, after all, this didn't work, and this battery does not fit in the old SatNav that died on me last year. I think I'll probably just do one of them videos where I put this down on the side, stick a nail in it, and we watch it smoke for a few minutes.